Hello again, fourth graders, and welcome back to Math Workshop. Friends, today's lesson is a doozy. So this is going to require really close attention and lots of slow, steady work, okay? Warning, warning, disclaimer, disclaimer. Be prepared for some tricky problems today. You got to be on the lookout and have your eyes open and paying attention. So today we're going to continue our practice of subtracting fractions. Yesterday's lesson was all about subtracting fractions that are easy peasy lemon squeezy, where the denominators sometimes are the same and sometimes aren't. But in today's lesson, we're going to talk about subtracting mixed numbers. You remember what mixed numbers are, right? Mixed numbers are those ones where you've got a whole number and a fraction. It's like having a dollar and some change. So just like there were two options before when we were learning how to add mixed numbers, there are also two strategies for subtracting mixed numbers. So option number one is to do the exact same thing that we did with adding mixed numbers. Make two new problems, solve each problem, and then put those smaller answers back together. Here's an example of what I mean. Our original problem is called 3 2/3 minus 2 1/3 equals P. Now our job is to create two smaller problems. Remember how we do that? First, we subtract the whole numbers, 3 minus 2. Then we subtract the fractions. Big number first, then little number, 2/3 minus 1/3. After we do that solving, 3 minus 2 equals 1. 2/3 minus 1/3 equals 1/3. Then we take those two numbers and we put them back together. And our answer is 1 1/3. Easy peasy, right? Very similar to what we did when we were adding mixed numbers. Create two smaller problems and go at it. There's also another way, just like there was with adding. The second way is, you guessed it, option number 2 is make improper fractions and then subtract. So remember that strategy of rock around the clock tonight. We're going to rock around the clock and create new fractions. Same problem. 3 2/3 is the same as what we did up top, minus 2 1/3. So if we're going to make improper fractions, remember that rock around the clock strategy, right? First, we go to the denominator and we rock around the clock clockwise, multiplying along the way. 3 times 3 equals 9. Then we keep on going, rock around the clock, back to the numerator, but this time we add. So 3 times 3 was 9 plus 2. Now the new name for this fraction is 11/3. Same exact fraction, same value, different name. When we rock around the clock for this fraction, we start with the denominator 3, rock around the clock clockwise, times 2 equals 6, rock more around the clock back up to the numerator, but this time we add, plus 1 equals 7/3. Now we can subtract these two new fractions, these two new improper bobblehead top-heavy fractions. So we can take 11/3, which is the same thing as 3 2/3, minus 7/3, which is the same thing as 2 1/3, and subtract them. And when we do the subtraction, we still get 4/3, and 4/3 can be reduced to 1 1/3. So our two answers, 1 1/3 and 1 1/3, they're the same. There is a trick though. So I want to show you, very, very important. So if you haven't been sitting up and paying super close attention, warning, warning, get out your pencil. There are questions that are going to trick you. Here's what you need to remember about subtraction. Sometimes the subtraction is possible. You have a big number and you're taking some away, so you'll have some left over. So if you can subtract the numerator, the whole numbers, and then you can subtract the fractions, go ahead and do it. But sometimes that isn't possible. Here's an example. 6 1/12 minus 4 7/12. So if we use option 1 and we turn this into 2 separate problems, right away our antenna should go up and say, huh? How do I do that? 6 minus 4, I can do that. 6 is bigger. I can take 4 away and I'll have some left over. So I can do that part. But 1/12 minus 7/12, if I only have 1, can I give 7 away? No, that's not possible. So strategy number 1 would not be optional here because that is not going to give you a real answer. So we have to do a little bit of work in order to be able to solve this problem. It is possible. We just have to do a little bit more work. So this is kind of tricky, and you've got to really pay attention to make sure that you're doing all the right parts. So put your best listening ears on, sit up nice and tall. Here's how we do this. We want this number to be bigger than this one, right? Because we have to have a bigger number to start with so that when we can take some away, we'll still have some left over, right? So what we need to do is we need to transform this mixed number into an improper fraction. We're going to use strategy 2, but we've got to make sure that we make the improper fraction bigger than this one over here. Right now, it isn't going to turn out bigger no matter what we do. So we have to do some work to it. Here's how we do that. Are you ready? First, 6 1/12 needs to change into an improper fraction that's bigger. Here's how we do it. We take 1 whole away from the whole number. So instead of 6, we're going to take 1 away from that whole number, and that's going to turn into a 5. We're going to give that whole number to the fraction. So this is what it'll look like. 6, we're going to take 1 away from that, and it's going to turn into 5. We're going to take that 1, turn it into a fraction, and give it to the fraction side over here. 12/12 is the same thing as 1 whole. So do you see how we just moved it over to the other side? So now, instead of 6, we're going to make it a 5. And we're going to change this fraction's name into 13/12. Friends, this is still the exact same thing as 6 1/12. It's still got the same value, but now look what we can do. When we go back to strategy 1, we can say 5 minus 4 is still possible. So even though I changed the whole number to a 5, I still have enough to take away the smaller number. See? Now look what this does though. Now, instead of 1/12 minus 7/12, that wasn't possible. But now my fraction is different. See? Now I've got 13/12 minus 7/12. Is that possible? Yes, I have 13. That's a bigger number, and I can give 7 away and still have some extra. So it's exactly the same thing as borrowing in regular subtraction. Remember when we have to go over to our neighbor and cross out that digit, make it a smaller number, and then loan that 10 to the other side? That's exactly what we're doing. We're borrowing from the whole number, and we're giving it to the fraction, right? We're just doing a little borrowing. That's all we're doing. So then we can go ahead and solve just like we did with option 1, right? We can solve for the whole number. 5 minus 4 equals 1. 13 minus 7. Can you figure that out? Good. 6/12. And then we're going to put these two back together. 1 and 6/12. Now, someone with a really smart eye is going to look right at that and say, 6 is half of 12, Miss Jungle, and you got it right. So if you wrote 1 1/2, that would be okay too. Either way, that's correct. But did you see how we have to change and do some surgery? Let me try one more right out of your journal to see if you're going to have to solve these yourself. So this one is one that you might see in your own journal. Let's read the directions. Solve the number stories and use different strategies for each one. So you can try drawing pictures, you can use a number line. Okay, here we go. The chocolate chip cake recipe calls for 3 1/3 cups of milk. We only have 1 2/3 cup at home. How much more milk do we need? So it sounds like they have to go to the store and buy some more milk, and they need to know how much more to buy. So let's go read it again. We have to read it one more time and look for the numbers to solve the problem. And then we'll write our number sentence and find out what our whole is all before we solve. Okay, the chocolate chip cake recipe calls for 3 1/3 what? Cups of milk. We only have 1 2/3 cups at home. How much more milk do we need? What's the whole that we're talking about in order to be able to solve this problem? Well, I have part of a cup of milk, and I have a part of a cup of milk. So our whole is 1 cup of milk. We have a little bit and a fraction of 1, so that's our whole. So we filled in the whole box. We're all done with that step. Now let's do part B. Let's write our number model with our unknown. The big number is 3 1/3 cups of milk. We know we're going to be doing subtraction, so we can fill in the subtraction operation symbol. And we have 1 2/3 cup at home. And the mystery is, how much more cups of milk do we need? So we have a big number, a small number, operation symbol, equal sign, and unknown. A letter of the ABCs, a variable. Now we have to look and see, okay, let's try option 1. Can I solve these problems? Well, let's see. 3 minus 1 is possible. 1/3 minus 2/3? Uh-oh, I can't do that. So I have to do some switching around. I have to make this guy an improper fraction that's bigger so that I can do my subtraction. So do you remember how we do that? 3 1/3 is going to lose a whole number over here, and he's going to add it to the other side as a fraction. And since our denominator is 3, in order to make it one whole, we have to have the numerator and the denominator be the same. Now, since we took 1 away from the whole number, our new whole number is 2. You see how we got that? Then we added another 3/3 to our fraction side. So now all together, we have 4/3. We have the exact same fraction. 2 4/3 is exactly the same as 3 1/3. It's just written in a different way. Same value though. Now we can rewrite our subtraction problem, 1 2/3. Now let's look and see. 2 minus 1. Can I do that? Yes. 2 minus 1 is 1. Okay, cool. 4/3 minus 2/3. 4 minus 2. Can I do that? Yes, I can, because 4 is bigger than 2. So now let's put those back together. 2 minus 1 is 1. 4/3 minus 2/3 is 2/3. How many cups of milk do we need to get at the store? 1 2/3, but don't forget your unit. Cups of milk. Without the unit friends, you don't get your full points for your answer. Does that make sense? So when you're going into your journal work today, be on the lookout. Have your eyes peeled. Make sure that you can do both parts of the question. Don't just assume that you can. They might trick you, just like this one did. And be on the lookout for those tricky ones that you have to rename and turn into something different. Give this a try today. Check your work. If you notice, hey, I'm on the right track, I totally got this. Awesome. Go and do the exit ticket, then swing back and do your math boxes. If you're really on the struggle bus with this and you want to do a few more examples with me before you try your exit ticket, hit me up in the chat. We'll get together for a small group or a one-on-one conference. We'll do some together before you try your exit ticket, and then you can swing back for math boxes. Okay? Best of luck, fourth graders, subtracting mixed numbers. Off you go.